I messed up, so I went home late. And then somebody had the gall to say, you probably could have done this time anyway. And I was like, excuse me. I said, now I was like 15 minutes.
Or are you gonna go to
Stop. So I showed them.
not quite top, right?
Well, how is it
But I'm not gonna let you.
If you just prove light improves
It's
light.
basically all the same. Is there a benchmark on
Nobody knows job.
I think in undergrad
I love taking your
it was no, yeah, no, it's modular like application. It was
All right, folks. Thank you for coming out for our April meetup. Really exciting talk we have here today on Research Computational Data Science at CHOC. So welcome. Just want to make a quick note about our sponsors. Do you want to talk about?
Sure, yeah, okay. So Chapman just started a wonderful Master's in Electrical Engineering and Computer Science, or EECS for short. It has a data science track, and it is something that I have designed a lot of the, not a lot, some of the curriculum for, and am teaching in the fall and spring of next year, Statistical Machine Learning 1, so very exciting. If you're interested, if that's something that you want to do, get your master's here, definitely come talk to me. It's an excellent program, and I will say, when we started it, I polled all of my data science friends, and they said that having a degree in electrical engineering and computer science was still very impressive and communicated technical rigor. So even if you're in data, it is a great degree to get. So consider, if you want, you can talk to me about it.
Thank you. Just want to give a shout out to UCI as well, the CHOC School of Business and the Master of Data Science program. We do several programs with them every year. If you're interested in just keeping up with us, here's some of our social media stuff, our GitHub, Slack. Some updates on events coming up. So our biggest event of the year every year is an annual hackathon that is at UCI. It's going to be at the CHOC School of Business. It's a really fun event. It's 2 full days. The first day starts with a kind of like refresh tutorial on a few different, frameworks or platforms. I think this year we're going to do an introduction to Arrow and DuckDB in both R and Python, and then there will be a feature engineering course, or a walkthrough. And yeah, it's really fun. It's like, what can you come up with a large data set in 24 hours? It's kind of open-ended, but it's a lot of fun. And let's see here, May 15th. We haven't posted the Eventbrite for it yet, but there's going to be an event at the Master of Data Science program, so I think the College of Computing over there, and it's going to be on navigating the present and future of Gen AI in production. Speakers are still TBD, but we do have someone coming from Amazon who is a senior solutions architect specifically within this space, and he's like a wealth of resource for Gen AI in production, if you will. And then our May meetup, just like this one, I think we're still TBD on the date, but
We have a date.
do we?
The new one.
Okay.
The 29th?
Okay, well, there will be a meetup in May.
The week after the 15th is when it will be. So, yeah. Okay, and then
we have machine learning workshop May 25th. It's gonna be at UCI. It's gonna be taught by a professor from Cal State Long Beach, Dr. Olga Korosteleva, and yeah, it's gonna be machine learning. So it's gonna be a full day workshop.
She's done a lot of workshops over the last 5 years or so. She's incredible. The last workshop that we collaborated with her on was an advanced regressions course where she introduced, like, I don't know, maybe 75 different algorithms that were implemented in R or Python, like stuff I've never heard of. She actually taught me a lot about different ways of looking at the same problem, if you will. So you think a regression is a regression, like an OLS regression, but there's actually a lot of different ways that you could go about that kind of problem. So anyway, yeah, she's really great. And then, yeah.
Yeah, okay. I would like to introduce Quinn Gates, who is actually a friend of mine from graduate school. He has a degree in mathematics and then a master's in computational and data science. He is currently working at CHOC, specializing in machine learning, image analysis, and data services. And he's going to talk to us a little bit today about all of the work that our data team at CHOC is doing. So please welcome Quinn.
All right, we're gonna plug in and see if my computer decides to work. Okay. Is there anything I need to change, Chelsea?
I think so. What did you click on again?
You want to try unplugging and plugging one more time?
Yeah.
All right.
You gotta blow in the cartridge too while you.
Yeah.
You should probably turn it off and then on.
There we go. Okay. Well, hi everyone. My name's Quinn. And yeah, I am right now a research computational data scientist at CHOC. I got my math degree here at Chapman. Then they asked me if I wanted to stay for my master's, and I said no. And then they said, please. And then I decided that would actually be really fun. And so then I got my master's in computational and data sciences. And then through some connections that I made here at the school, I found my way to working with a clinician at CHOC, and then through that I started working with Louis, who couldn't make it tonight, but he's my boss at CHOC, and then now I'm there full time, and it's awesome. Yeah, this is recycled a couple times. So we always like to remember our mission and vision at CHOC, so I'm just going to read that out real quick. So our mission is to provide research data, computational, and data science research services at CHOC and conduct independent research towards advancement of pediatric medicine. And to be, our vision is to be a leading national destination for computational data science in pediatrics. This is our team. You'll recognize a couple more of my team members in the back. Hi guys. They're here to make sure that I don't say anything too silly. Yeah. So that's us. We cover a huge array of research areas. So we do everything from data services for clinicians at CHOC when they want to do independent research. We also come up with some of our own research projects. We do machine learning, we do statistical models, and yeah, kind of anything having to do with data at the hospital. They come to us and we either point them to where they need to go or we do it with them. So it's really fun because we get to work with clinicians along with like data scientists. So you kind of get to speak two different languages while we do the job, which is really fun. That's just me again. I think Chelsea covered it, but master's in computational data science, bachelor's in mathematics, and I do image analysis, machine learning, statistical modeling. So the first project that I want to talk to you guys about is our CPAP failure in preterm neonates. So this is a really cool project, and this one came from one of our clinicians at CHOC. The idea is that preterm babies are born with very underdeveloped lungs. It's pretty much the last thing that develops in the baby. And so when they come out, they need some kind of respiratory assistance. And there's kind of two paths that they can take for that assistance. One of them is CPAP, or continuous positive airway pressure, which essentially is, it's the same thing that is used for sleep apnea. And so it basically keeps pressure on your lungs, and it's, instead of breathing for you, just keeps that constant pressure, and it's gonna keep your lungs from deflating, and it's just going to kind of help you through breathing. But that's not always enough. Sometimes that's not enough for the infant, and so they need invasive mechanical ventilation. And so they go through intubation, and a tube is put down the throat, and basically the machine breathes for you, in and out. So it's not just a positive one-way pressure. Now, ideally, the infant is going to make it on CPAP. But if you fail CPAP, so like all of a sudden CPAP is no longer meeting the infant's needs, and then they move to mechanical ventilation, that is significantly worse than if they had gone mechanical ventilation first. So our goal in this project is to see if we can identify and flag infants that are likely to fail CPAP and be moved to mechanical ventilation anyway. And so for those infants, they would be better off put on mechanical ventilation early. So that's what's going on there. And so here's kind of a timeline for how that would go. So we have a preterm birth, we have RDS, or respiratory distress syndrome. And normally what would happen is they'd go on CPAP, and then at some point down the line, if this infant fails CPAP, they have CPAP failure, and now they're in an emergency encounter, they're put on invasive mechanical ventilation, or IMV, and that can lead to their potentially very severe morbidities. Our goal is to put in this elbow in here where we have our model that says CPAP failure is likely, and so instead of putting them on CPAP, we're going to move them directly to invasive mechanical ventilation, which is going to greatly mitigate pretty much all the same morbidities that, and yeah, so that's our goal with this. This study is funded by Casey Pharmaceutical, which is an Italian pharmaceutical company, and then the clinician that we're working with is Dr. Mikkel. And yeah, so a couple like stats just to go through those also. That it's pretty common that these infants are like or have respiratory distress syndrome. So nearly 40%. In our data set, we actually were closer to 60, but we had a pretty strict definition for, we wanted to cover everything essentially, so we have a pretty strict definition. And then 25 to 38% of these infants fail CPAP and are moved to mechanical ventilation. The reason that's so, oh yeah.
Do you want questions now or?
Oh yeah, and totally ask questions while we're going, because if you forget about them, then that'd be a bummer. Yeah.
So does the air pollution in LA or Orange County have anything to do with the higher percentage of?
So we didn't actually, so, and we'll talk about this too in a minute. We're doing a multi-center across the nation, and we have information for, we have basically a one-digit zip code, which is going to give us general locations throughout the nation, but we don't have anything specific enough to do any geocoding and add in like air quality. That would actually be interesting because one of the things we're going to do after this is use CHOC's in-house data, which obviously is a lot more granular, and we can do a lot more with it. So it could be interesting to add in like a level of air quality and see how that does. So thank you for the idea. But yeah, at least for this part, we don't have any kind of geocoding for air quality. Yeah. Yes?
So are the neonates discharged on CPAP, or are they in CPAP?
That's in the hospital. So yeah, during their like stay during their stay in the NICU, they'll come out. They'll be on CPAP, kind of for as long as they need it. A lot of the time, the NICU stays are pretty long. So I don't think that they're going to be on it the entire time they're there, but when they're needing respiratory assistance, then yeah, they'll be on the CPAP. And I have a picture of what it looks like too, so it's fairly comfortable for them. It's basically like a hat, and then it like goes down and covers their nose to keep pressure. The mechanical ventilation is obviously a lot more invasive, and I think it's going to have to be on them for a good deal longer, which it's traumatic having the tube go down your throat, but it's also traumatic being on it for so long. So that's kind of why the goal is to keep them on CPAP, but if they're going to fail, get them on mechanical ventilation early. Because again, the process of failing first and getting moved over to mechanical ventilation is way worse than just being on mechanical ventilation.
Yeah, that makes sense. I was just, the pulmonary outcomes with air quality definitely well established in general, but hospital air quality is very, very clean indoors. So
right,
they're indoors the whole time.
Yeah. Yes?
So 40%, and can you talk about the numbers? Like, are we talking about hundreds of babies, thousands?
I wish I had those numbers. I know. So this is, we'd have to like look at just like the bulk number of preterm births, and then I would say 40% of them are going to get there, but I don't have those numbers. We have the numbers for our cohort, but our cohort is filtered already just to preterm neonates. So that won't be like a very good representation of like just how many infants are dealing with this in general.
Right.
But
No, I mean,
Yeah.
I was asking more on like your hospital. Like,
oh, gotcha.
Yeah.
Don't know off the top of my head. And like this part of the study is going to be the multicenter, and then the second part, which we're still working on, is going to be the CHOC in-house. So we might need to get back to you on the CHOC in-house part side of it. Yeah, I saw a hand over here. Yeah.
So CPAP's always the primary treatment for.
So
before
it's
life.
assumed that if so for preterm infants, it's pretty much assumed that they're going to need some kind of ventilation, and so it's assumed, or at least that's one of the assumptions we had to make for the study, which is a limitation, is that we're assuming that if they weren't put on mechanical ventilation, then they were on CPAP, because there's not really it's coded for some hospitals, but not all hospitals actually will code for putting the infant on CPAP. But they will code for mechanical ventilation. So that's kind of one of the limitations, because it's possible that some of the infants that we have coded as passing CPAP might never have been on because the doctor didn't think that it was necessary. So that's a limitation, but that's one of the ones that Dr. McKell, and at least at CHOC's NICU and the NICUs he knows of, preterm birth, they're going to be on some kind of breathing assistance. We're assuming that's CPAP unless they specifically code mechanical ventilation. Yes?
So this data is multi-hospital?
Yes. It might be next slide, but we're splitting it up into two parts. So the multi-hospital uses Cerner Real World, which I think is now Oracle Real World. I can't say it. And so that data is nationwide, and it has its own limitations, but it means that we can get a lot of data. The CHOC in-house we're able to do a lot more with, just because now we'll talk about that again, I'm getting ahead of myself, but we're able to like connect it to imaging data, we're able to connect it to data from the mother. That's all stuff that we can't do with the real world data.
Yeah.
Cool. All right, here we go. Oh yeah, so here's pictures just to like kind of put yourself and like figure out what's going on. So CPAP, you have this cozy looking hat, and then positive airways, usually done through nose. They have some that cover nose and mouth, but at least in this case, it goes on the nose, and it's going to keep positive pressure on the lungs. Mechanical ventilation, tube goes down the throat, and it's doing the breathing for the infant. And this kind of gives a picture as to like that it just is significantly more invasive and traumatic for the infant. And here's our two approaches. So on the one hand, we have CRWD, now ORWD data. This is structured only, so we can't connect it to notes or image data, but it is multi-center. Yeah, and we're not able to connect it to the mother. We get a big cohort, so this cohort had, we have 555 neonates that qualified at the beginning of the study. Yeah, and then later we'll talk briefly, because it's still like underway, but with the CHOC in-house data, we get to connect that structured data to image, like chest x-rays and such. We're also able to connect to the mothers, and so any kind of like antenatal steroids, magnesium, and we can get like mode of delivery, because a lot of times that will have an effect on if they're put onto mechanical ventilation, and a much smaller cohort. So in that case, we went from 43,555 down to 1250.
Are there
Yes.
social determinants of health on that data set, or do you attach it to something?
There are. We only, I think for this one, are collecting demographic data. One of the fun things with CRWD is that it is messy, and a lot of hospitals don't code the same ways, or don't code things in general. So one of the big limitations is going to be missing data for everything. And so that is something, though, we would definitely have for our CHOC in-house side. And then pretty much a lot of these projects we do end up doing like a second round where we look at the same idea, and then introduce some social determinants of health. Yeah, but one of the fun ones, like we have like an asthma study that's using geocoding to look at air quality and how often they're coming to the hospital for utilization. It's like, yeah, cool stuff like that. Cool, we move on. Cool. So for this one, this is kind of saying the same thing. Multicenter, nationwide, de-identified, that's a cool one too, so it comes already de-identified. And then the tool we use for it is called Spark, which is it's an extension of Python that is pretty much SQL, but it's just different enough to be annoying. You can't just copy your SQL code and put it into here. You have to change it ever so slightly, which is super cool. And so yeah, the data we collected for this one, we have ID variables, we collected demographics, laboratory results, gestational age, birth weight, ventilation data, so CPAP or mostly mechanical ventilation, and timing is really important for this project, so timestamps for everything. And one of the big things there is we want to have this model, at least for this stage of the model, we want to basically have our first round of vitals and be able to have this running where we can flag them immediately for if they're going to need mechanical ventilation. We don't want it to, we don't want it to have to wait a long time for them to collect extra data. So this is stuff that's pretty much collected right away and anyway, and so we want to have it quickly. In future iterations, we'd like to have it be real time. So as it can watch all vitals all the time and then like flag whenever it's needed. But at least this iteration is just looking at our first vitals. And yeah, question?
Sorry, so I assume you're pulling this directly from Oracle system, or is it dedicated? Okay.
Yeah, it's it's directly from them. At least I don't think this is like a third party.
And then the timestamp, so you guys are shifted since it's de-identified?
Yes, so there is some like shift to it.
Which explains the 2004.
Probably. Yeah. But it should, at least from what I understand, the dates should all have shifted together. So if we have a time of birth and the first vital signs, they should have shifted the same.
Yeah.
In theory, it's messy data, so so we work with what we've got. But at the very least, since we're just taking the very first, we're taking the first valid vitals. And so if you have a whole bunch of like invalid vitals, so say, whatever they're taking the vitals on is like reading nulls, once they plug it in and it gets a valid value, then we like take that. It's also fun, you'll have like units are fun because a lot of times people so Celsius versus Fahrenheit, the classic. So they're taking like the temperature, and they either don't put units, so you kind of have to guess, or it's units that obviously aren't correct, or it's values that are so horrendously incorrect. There's no, like, I don't know why this baby's temperature of the sun kind of thing. So. Yeah, somebody putting it in Kelvin.
Clean it yourself then?
What was that?
You guys clean it yourself then?
Yeah, so we get it in. We do as much the cleaning as we can on the like Oracle side, just because the data sets are very large, and Spark is pretty good at like handling it. And then I usually end up doing as much as I can there, and then I'm just more comfortable in R. So I'll pull out and do my final cleaning and like categorization and everything in R. Even like coding for demographics. Actually from Ricardo, he has a great code that does that. And so I usually end up using that code because I can't find a version of it in here that does as good of a job. So yeah, we do all that cleaning. It's a good time and takes up like probably 80% of the time. Once you're finally ready for modeling, it goes so fast. Cool. That's data collected. For this project, we use extreme gradient boosting. Does anybody know extreme gradient boosting? I'm going to do my best to explain it. Cool. If I do a horrible job, I'm really sorry.
Oh, I'm terrible at explaining.
So extreme gradient boosting is essentially you're combining a whole lot of weak learners. So it's an ensemble, like voting kind of learner. But each, it creates these weak learners in a sequence, and it'll learn from each sequence before it. And so basically each one of these weak learners is taking not the whole set of your variables, and it's creating a decision tree or doing a random forest for those variables, and it goes down and then it learns and then goes to the next weak learner. These different regression trees are ranked and actually given like different voting power when you come to put them all together. And it's one of the reasons that people are liking extreme gradient boosting is that you're actually able to look in and see what features ended up being the most important. So you can do some feature analysis in that sense. And how that happens is each of the trees, as they're ranked, you'll start to see certain variables show up as being more important, or you'll see certain variables showing up in the important trees more often. So say you have 1,000 trees, 100 of them are like the top performers, and in this case, FiO2 keeps popping up in those trees that do well. Then using a gain function, we're able to figure out that FiO2 then is going to be one of the strongest indicators of CPAP failure. To make sure I'm hitting all of it. Yeah, so it's ensemble weak learners. They learn from the ones before. Different importance. Oh yeah, overfitting is minimalized by basically a learning limit. So it's called eta, and that's going to choose, or it's going to stop the learner from overfitting, because it's not going to, oh my goodness, it's words. The next learner is only going to learn so much from the learner before it, because if it was learning too quickly, it might start relying too much on a single variable. So each weak learner is going to realize, oh, like let's only look at FiO2. So eta is going to be able to limit that, and so you're going to get a more robust model. You set a max tree depth instead of like a set depth, and so it's going to, if it doesn't need, like let's say our max tree depth is 6, it doesn't actually need to go the whole way. If it minimizes the residuals before it hits 6 or it hits some limit, then it's going to stop and have a simpler tree, which is going to stop it from being over complex. And then breadth first, not depth first. So that's kind of that process of, as it's making the tree, it's not going to make too many branches if it's able to minimize your residuals first. And one of the biggies, it actually can function pretty well with missing data. So working with the real world data, like I was saying, there's a ton of missing data in it. And so it's nice to have a model that more or less on its own is going to be able to deal with that missing data, pretty much categorizes it in its own group. We'll see that later. I have a graph that kind of shows how it looks at your missing values. So that's a big plus here, especially working with sparse data. Okay, questions? Yeah.
So what is it exactly that you're modeling? Is it CPAP failure, yes, no, or?
Yes, oh yeah, sorry, I should have done a better job. Yeah, we're doing this as a binary yes, no. Okay. And we're defining CPAP failure as the need for mechanical ventilation. Again, because we don't actually have a code for failing CPAP and moving over. One of the things Dr. McKelkey always says is like, if you ask 100 doctors what to define CPAP failure, you'll get 100 answers. Like it's not a super like set definition. So our definition, came out to need for mechanical ventilation. That means failed CPAP. And yeah, it's just a classification, yes, no.
One more.
Yes.
So why did you guys choose this one? If you can explain the process.
Yeah. So the main one is we wanted to be able to have that that look at the features. And see like what ended up being the most important predictors, because a lot of the literature already says that FiO2 is the best predictor. And a lot of those models are statistical models, or actually all of them. This is the first machine learning model that we know of that's been used to do this. And so we wanted to be able to compare to previous literature and see if FiO2 is indeed the best predictor. It is. But we'll actually have a better look at that later, because it might be interesting as to why it is.
Another question
Yes.
about that process. Why did you end up using XGBoost as opposed to some other implementation of boosted trees? Was it just that that's the standard? Was it speed? Something in the algorithm?
There's not a reason. More or less, it's the one that worked. we coded and worked. Yeah.
You should try cat boost so that you can put cats on your slides next time you present it.
Gosh. Guys, I gotta go. I'm sorry. There's not enough gas. Yeah.
Are you using the Spark implementation of XGBoost, so like their boosted tree implementation, or are you using XGBoost?
XGBoost.
Okay.
So by now this is all moved to R.
Are you using tidy models for hyperparameter tuning? Or are you hyperparameter tuning at all?
We're using Carrot.
Okay.
Yeah.
Cool.
And we did a grid search for optimizing our ADA and tree depth. And
You should check out tidy models.
I should.
The parsnip package. If
Okay.
you're comfortable with Carrot,
Okay.
it's the same thing.
Yeah, tidy models XGBoost is a lot easier to run than regular XGBoost.
I love
Yeah.
to hear that.
There's a
And you can pipe everything.
Yeah, you can pipe everything. There's a package called Embed. They have a function called Tune Race ANOVA, and
Cool.
so you can have a massive grid.
Cool.
Not that you need one, but you can have a
Want a
massive
massive
grid, and then it'll just train to completion a set amount of models, and it will keep running like simultaneous ANOVA tests, comparing like model
Yeah.
performance. It's really cool.
And what's the name again?
Well, Tune comes as part of like the
Tiny.
the Tidy Models collection of packages.
Okay.
This package is called Fine Tune by
Okay.
the same team. It's just not one of the default installed packages.
Cool. Wifey ready?
Okay.
Thanks, wifey. Cool. Before I go on, everything good? Cool. Right along. And this was another way of trying to explain it. I just pulled it from Google because I didn't know how well I was going to do explaining it. But it kind of starts with your pseudo residuals, your ensemble of weak learners, or in this case we use regression trees, and then those are learning from each other to minimize a loss function, and then we get that until we either reach our max number or we minimize our residuals, and then it's an ensemble learning. So voting process, and it's a weighted vote because all the different regression trees are ranked. Cool. This is to prove that I did it in R. Pretty much the only reason it's there is because like it's an R thing. I'll show a little bit of R code, but I hate looking at it, so we're gonna move on.
Could be ChatGPT that produced that.
I would
Oh,
never.
That's true. No, but you just copy and pasted it into R.
You know, it's actually funny. One of the things ChatGPT actually did kind of good job on is I had a Shiny app and it wasn't working. And I put it into ChatGPT and said, "Why isn't this working?" And it totally fixed it. I was like, yeah, so that was cool. So we're back on topic. YXGBoost, and this is the main thing. We're able to look at our gain function and see the importance of different variables. So, oh, question's coming. So in this case, we were able to see that FiO2, at least for our model, was the strongest predictor, followed by systolic blood pressure, temperature, PaO2, and then finally birth weight, which we thought was going to be one of the stronger predictors. But I think missing this did have an effect on that. And then we have some of our other vitals, heart rate, PCO2, respiratory rate, systolic blood pressure, insurance made it in there, governmental insurance made it in there, and self-pay, so the different payment options. And then sex was our very last one that was important, but it was pretty small.
Were payer rate mixes like in there is kind of maybe kind of its own version of SPOH a little bit?
Probably, yeah.
Okay.
Yeah, I know like for a lot of the hospital stuff, they like to include those values. Yeah, so made it in. Cool.
What is FiO2?
FiO2 is, I'm gonna butcher it. It's one of the vital signs that they take, but one of the problems with this is they don't take it always, and I do such an awful job. Because it's not the same thing as SpO2. It's not blood oxygen. Yeah.
Vital sign. It's a vital sign.
It's a vital sign, and
Okay.
like it's a horrible answer, but
That's
that's
good
kind of what it
enough.
comes
That's
down to. So I just, whenever I see it, I'm like vital sign.
Yeah.
Fraction of inspired oxygen.
There we go, and that's one of the ones I'm supposed to know. Don't tell Louis. Yeah, fraction of inspired oxygen.
Concentration of oxygen in the air mixture that a person breathes.
There we go. Yeah, so instead of blood oxygen, it's like how much oxygen is in basically the air that's coming in and out of your lungs. So like basically when you're hooked up to one of these respirators, it's one of the values that it influences how much oxygen gets mixed in with like positive pressure on your lungs or into the ventilator. And it's one of the values that it takes while doing that.
A quick question.
Yes.
Is that vital sign or that measure given to all prenatal babies, or is just the ones that have respiratory
So
issues?
that's one of the main struggles with it, and it's actually one of the reasons I think it's it's an interesting one to be like our top predictor, because it's not as common as like the basics. It's not temperature, heart rate, like those, because pretty much everyone, when you're in the NICU, you're gonna have to be hooked up to getting those vitals. FiO2 is not as common, mostly because it's on the CPAP machine or on the mechanical ventilation machine. So that's like one of the reasons it's like kind of odd, because like if you're not put on one of those machines, then it's not there, or sometimes it's not there even if you are on one of the machines. So that's one of the missingness problems with this part of the data. When we move over to CHOC specific data, there's a lot less missingness with it. And I don't know if it's on the next slide, but we'll basically see that just not having an FiO2 value makes it significantly less likely that you're going to have CPAP failure, which is one of like our hurdles, one of our big points like the discussion. Because again, like all the previous literature also recognizes FiO2 as one of the strongest predictors, but its missingness is a big portion of that, which is interesting. Yeah.
Is the pharma company that funds it a med device company by chance?
You know, I don't know.
Like, do they have a vested interest?
Yeah,
in
no,
identifying that?
I hadn't even thought of that. I don't think they do medical devices, but that's purely that's just me thinking. I have nothing to back that with. Yeah, but it would be interesting. Question? No? Yes.
So I'm wondering about that missingness. Is this something that is FiO2 something that's always taken at a certain time after birth?
No.
Yeah, so I'm wondering if there's some clinical decision that's
Yeah.
involved in that missingness.
And so that's my thinking as well would be like if a doctor thinks it's necessary to take an FiO2 value, is that putting you already into a new group of those that the doctor thought was necessary to take this value. That's one of our big like discussion points is like, is this like, how strong is this predictor really, like is the model, and the model's not as good. It's not actually that much, it's not horrible once we take it out, but FiO2 definitely strengthens our model. Cool. Moving on. Also, how am I doing on time? So I can
You have
skip
like
a lot of
30
stuff.
more minutes, 45 more minutes.
Oh, sweet. Cool. I'll just keep talking.
We have the room until 8:30, so.
But you
Cool.
don't have to use that. I mean, you're welcome to.
Oh, just you.
It's
Yeah,
not an
this is
obligation.
one of two projects I wanted to talk about, and the other one's fun.
Okay, cool.
Yeah, so results, we basically were able to say that we can predict with a pretty high degree of accuracy our CPAP failure. So we have area under the ROC of 0.91 with a confidence interval from 0.90 to 0.92. F1 score of 0.87. Those are our pretty graphs. Yeah, so we're happy with those numbers, but then we can see on the next slide. Yeah, so this is where we can kind of see the missingness and why each variable did as well as it did. So first one, FiO2, you can see the values that we have that are not missing are all the blue ones. And you can see the red line going through it is our showing the trend for like how that value is going. And so basically we're saying like from 20 down up to about 37 for FiO2, the higher your value, the more likely you are to fail CPAP. And then it kind of levels off and stays fairly even, but kind of drops a little bit, but that's where we have like sparser data, so we kind of say it more or less evens out. And these purple values are going to be all the missing ones. So it's like on the graph, but it's not like it's not given like a really numerical value, but you are able to see the distribution of like where those fall into the SHAP value, which is how we identify how important a variable is.
Was your feature importance based on SHAP or like the, yeah.
And you can see that with all the purple values, they all fall fairly below. So this is kind of lending towards the lack of a variable is going to make it less likely that you fail CPAP. And so missing data is definitely like a big part of using the Cerner real world data. And while this model does like handle it, in the future we want to figure out if we can, it's too missing to really do a good job with imputation, I think. But then we want to figure out if we can do something better, like define our cohort better. Of course, once we move over to the CHOC side, it's not going to be as much of an issue, and we'll be able to include more data points that could potentially be even more important. So we'll see there. And oh yeah, incorrect data. Baby's the temperature of the sun. Not good. And yeah, compared to, and yeah, this is the first model that we know of that uses machine learning opposed to statistical modeling, looking at this data. So we're super happy with our numbers right now, and yeah, really excited to move forward with it.
Is a 1 or a 0 in your case that it goes
0
into failure?
is pass, 1 is fail. Yeah, cool. Going on. So on the positive side, if we can get a model that does well, we're turning that rescue encounter of moving an infant to from CPAP to mechanical ventilation into an intervention encounter, which is really going to mitigate the morbidities for the infant, which is super awesome. And of course, we have lots of opportunities to expand the study, which is going to be when we go into our next part. Approach number 2 is using CHOC's data. Oh yes.
Why is it worse to go from CPAP to mechanical intervention than directly to mechanical intervention?
Basically it's traumatic for the infant to fail CPAP. From how I understand it, and this could be not super correct, but your lungs and the muscles around your lungs are the last things to develop. And so if you're on positive airway pressure, it's keeping it inflated, but sometimes that's still not enough, and you can have like the lung collapsing. Basically, it's traumatic and hurts the infant more than if they just gone straight to mechanical ventilation, which has its own comorbidities that we want to avoid. But basically, yeah, the process of failing first and moving to mechanical ventilation exacerbates the comorbidities of being on mechanical ventilation. So that's why, yeah, it's ideal to just be on mechanical ventilation first if you're going to fail CPAP. So it is that balancing act, because if you make a model that's too strict, that's moving everybody to mechanical ventilation, now you're putting infants on mechanical ventilation that don't need it. And if the infant doesn't need it, now you're introducing those comorbidities that come along with the mechanical ventilation. So now you're hurting the baby. So it's that balancing act's important. That's why a lot of it, like this is going to be a flagging device, so that the doctor still is going to be making the final say. But especially like at NICUs or other hospitals, if they don't have the great staff that we have at CHOC, this model could help like those doctors in making those decisions. Because yeah, it's a tough decision to make if you're just kind of looking like, I think we need to put them on mechanical ventilation. You can't back it, and now you're always curious if you put a kid on mechanical ventilation that didn't need it. I don't know if I wandered a little bit, but did that answer your question?
Yeah.
Okay, cool. Yeah.
So is the rescue versus interventional basically you're kind of buying more time to switch to mechanical, so maybe there's less risk of infection trying to do it quickly?
Yeah, and it's also like we'd like to see if there's kind of actions that the doctor could take to lessen, like, so infant gets flagged, this infant is likely to fail CPAP. Does that mean they're going to fail like imminently? Are they going to fail in like 30 minutes, or is it going to be farther down the road? And are there steps that the doctor can take so that it pushes that time farther back, or makes it not happen at all? That's going to be something that we can look forward or look into in the future. Because right now we're just looking for that like flag, and it's kind of going to be up to the doctor to decide: does that mean we're going to take steps to try and not move to mechanical ventilation, or are we going to go on mechanical ventilation now? Yeah, it's really it's not. That's one of the fun things of like doing these kind of jobs is like I'm not a doctor, So like I don't really get to say this kid needs to move to mechanical ventilation. All I can do is say, like, using, you know, a huge population, it's likely that this infant's going to fail. They should get moved over, but the doctor still needs to take the whole situation together. One of the cool things working for like the hospital is we really have a focus on like a single kid. Like we can talk big populations all the time, but if it doesn't help a single kid, then we're not doing our jobs right. So I really like that mindset at CHOC, because everything's going to be, what do we call it? It's like bedside to bench to bedside. We're always worried about the kid that has this issue. How can we best serve like that individual kid? And that comes from like the data scientists and the doctors working together, not me trying to figure out if I can save the kid on my own. And yeah. But it's cool. Did I see another hand? Yeah.
Yeah, so I was just wondering, for your model, you said that CPAP failure was defined as someone having to transition into mechanical ventilation?
So it's that's the tricky part with our definition, is we didn't define it as the transition. We defined it just as them being on mechanical ventilation, with the assumption that they either started on or basically with the assumption that they started on CPAP. And there are definitely holes in that definition, because there's not a code that we can use for the transition. We only have the code for being on mechanical ventilation. So definitely a limitation. Even with our in-house data, we have the same issue. So again, assumption, they're on CPAP, they're on mechanical ventilation, we're going to assume that that was a transition.
Do you guys also factor for the time from maybe birth to when they were?
Yes, and I guess I didn't have that in there. So we're pretty much interested in the first 3 days of life. So within 72 hours of birth, we want to know basically if they got moved to mechanical ventilation. If they got moved afterwards, we're not considering that as part of our definition. We're only looking at the first 3 days. I saw 2 hands, so I'll start over here.
I'm just wondering how your data is collected for the in-house stuff, because I see like the model can influence the doctor's decision, and then if the doctor puts the common ventilation, and then that shows up in the data that's like influenced by like.
Yeah. So that's a super interesting topic that we've brought up a couple times internally, trying to figure out basically what we're going to do when we start implementing. So like right now this model isn't implemented, so the data I would consider like safe. But yeah, once your model is influencing the decisions of the doctors, can it go into the model? I would argue no. And so now you have to decide, are we going to have a cutoff? And how are we going to have that learning go forward? And we're looking into ways that we can still introduce either some or all the data with whatever augmentation. But I don't know what that looks like right now. But it's definitely a super interesting like topic that's going to be interesting for, like we have sepsis models for how likely sepsis is. We have readmissions models for how likely somebody is to come back. But now, like, let's say somebody's likely to come back to the hospital, and we do some kind of interaction that's going to limit them coming back and using resources. Like, do they need to stay longer at the hospital? Do they need to have like a telecall or something like that? Now, do they get to go into the model? Again, I'd argue no, but we don't want to just all of a sudden have a cutoff as to what data we can use. Like, so, super interesting question. I do not have an answer. And one more? Yeah.
Has there ever been a case where they go from CPAC to IV back to CPAC, or like a different backup?
So I'm sure that it's happened. For all these, we're taking basically the first time that each event happens. So we're looking at the first time they're moved to mechanical ventilation, and we're considering that they went to mechanical ventilation. Because kind of once you go down that route, you've already exposed the kid to that traumatic experience. So going back to CPAP, I would assume that that does happen. Just because like once maybe the baby's stabilized, they can put it on something less invasive. But at the same time, the process of putting the tube in is probably the most traumatic part. So taking it out with the potential of putting it back in is probably not great. So it could go both ways, but I assume that once it's in, it's staying in for a while. Cool. Super great questions, guys. I love it. Good? Oh, yes?
So if you have a code, presumably there's also a code for CPAP, right? Or is there not a code for CPAP, and that's why we can't use it?
Pretty much. one of the other fun things with, Ricardo.
So, in the Springer real-world database, there's codes for CPAP, but it's combined with BiPAP as well.
Oh.
And it's not specific to just CPAP. There's some codes that pertain to the other devices along with CPAP, so like the airway tubes and things like that, that you can try to use. But again, it's not specific, so you can't guarantee that it's CPAP.
Yeah, so it's not definitive enough to really be helpful. But the mechanical ventilation one is more because a lot of medical billing or data comes down to like the billing for it, and we work with what we got. And so if there's mechanical ventilation, there's going to be billing code. Cool.
Yeah, medical health records are always created for billing first, and everything else is ancillary.
Yep.
Unfortunately.
One day.
Can you like use this to petition your hospital to like record data differently?
Well, so I have a couple friends that are nurses, and they, like, after I explained my job to them, they understood the importance of collecting data. But before I told them what I did, they didn't see the collection of data as like doing anything on the back end. Like they're very patient-centered, which is awesome. But if it takes too much time to record whatever variable that I think is super important, but they think that it's important to save time and move on to the next thing, I'm not gonna say who it was, but they would like just put in whatever, like if it was a drop down and they had to scroll the bottom down, put in the first one. And so that really messes up stuff on our end quite a bit. And I get where their like heart is, but then of course now I tell them that this is what I do, and they're like, oh my gosh, I'm never doing that again. So honestly, a lot of it comes down to, I think, education to the nurses on how important it is to get those values in there correctly. Because while they're, again, super patient focused and they're focused on what's right in front of them, and that's awesome, they can be helping a lot of people by making sure that the data they put in is good. So
data entry is not taught in medical school or nursing school, right? So
yeah. So I think, and as you know, the data science and medicine field grows, I'm hoping that that becomes a big part of, or at least a part of like the nursing school process, or just, yeah, everyone needs to be putting in good data because crap in, crap out.
For like technology to be able to bridge that gap, because like nurses and my wife's a physician, it's like the amount of hours she has to put in after she comes home is like ridiculous, and she's still doing notes and messages and labs. Like the last thing she wants to do is be like, let me make sure I have the right code.
Right. Or the right units. Like even if they did a great job putting in the stuff, like double checking that, again, your baby's not the key to the sun.
And I work in real world data, so like you, I explained to her, I'm like,
yep.
look.
We use it, it gets used.
But like I get it too, so I think you know, there's like a company called The Bridge that takes medical notes and like uses LLMs to kind of, like, I think that's where maybe a possible solution.
Yeah, because the notes usually do have, there's so many gems in the notes, and so we have a couple people on our team that are specifically focused on clinical notes and getting information out of it.
Yeah, that's gold mine.
Yeah, super cool. This is what we're going to be doing next. Yes. The same thing with CHOC data. So do we want me to talk about this project too or no?
Why don't you start?
I can kind of just blast through it.
Yeah.
All right, we're going to do our best to blast through it. So this is a super cool project looking at traumatic brain injuries or seizures post-traumatic brain injury. So essentially the outline for this one is kid comes in with a traumatic brain injury, and as they're being treated, a lot of times they'll be given AED or an anti-epileptic drug. And our null hypothesis is basically that that drug has no effect on the prevalence of seizures in the future. So we're looking either like lifetime afterwards or in the next week, month, or year, how prevalent are those seizures. And yeah, the assumption is that these drugs don't have any effect. So traumatic brain injuries, mostly caused by falls, but there's lots of ways that you can hit your head. And it is the leading cause of pediatric death and impairment. So figuring out if we can mitigate those the effects of AEDs, because there are negative side effects of those drugs. So again, if they're not necessary, then we want to stop using them, is the idea. So for this one, we use CRWD again, and you'll notice that we have a very not balanced data set. So here we have almost 400,000 patients, and only 16,000 of them received an AED, and 376,000 did not receive an AED. So already we have a huge disparity there. Also, after TBI is number of seizures throughout the rest of the lifetime that we have data for the patient. And for that, we have the first number is the median, and then the interquartile ranges are the next two, and you'll see that they are all zeros. And so we basically have, this would be a very zero inflated set. Also, we have, for sex, we have more males with TBIs. Who saw that coming? We have, and then for race ethnicity, we have, since this is across all of America, we do have pretty much half the population is white, and then kind of a bigger disparity through there. So basically what we're going for is we have a not balanced data set at all. So what we're going to use is a zero inflated Poisson, which is a mix of a Poisson regression for counting and a logistic regression model for predicting the excess zeros. Since we're blasting through, I'm just going to keep going. This is the model we're using.
Are you using BRMS or something like that for it?
I don't know. I don't think so.
No.
No. Oh, no, it's not. Cool. I did it in R. I want to go through this. Yeah, we can go through this. Okay, so for this one, it's using, forget the package name. Oh, there it is. PSCL is the package for it. And for this, we're looking at serum Poisson of after TBI, so all seizures. We're looking at sex, race, and then we are doing, oh my gosh, LME. Why can't I think of the thing? My brain's falling apart.
Mixed effects?
Mixed effects, thank you. We're doing a mixed effect look at medication as the divider there. So looking at our model, we can see that sex is highly significant, and we can also see that the medication is actually highly significant. So this would go against our hypothesis that there's no effect. This is saying that there is some effect from the medication. And we can look at a chi-square to see if we beat the null model. So we make our mole model just the intercepts. Yeah, and we do chi-square, and since it is highly significant, we can say that our model is significantly, or is better than the null model, blasting right through. And then this is a visualization of what that looks like. We faceted this across races, and then we're looking at each color dot is our sex, and then 0 is no medication, 1 is medication given. And in the visualization, we can see that pretty much in every case, a medication given is actually increasing the likelihood of a seizure. This is still super preliminary, so we don't have anything conclusive about it. We know that it's significant, and we're obviously going to look more into it, which is fun. But warning, because these are preliminary results, and so we can't say anything super conclusive. Enter at your own risk. Oh, and then I have a bunch of, we don't need to go through any of these. Basically, there are like other projects that I'm working on that I don't have slides for, so it's just kind of like the hypotheses for them. And so now I'm going to try and get our plug-in for the our conference coming up. CHOC is having a data science conference, May 23 through 24. Is it still free if you're a student, if you have a student?
Yes, there is a code for students.
Cool. If you're still a student, you can come for free. And we're going to have a hackathon at it, which is going to be super fun. That's hosted by AWS. Alina, do you want to say anything? Alina is like one woman show on this. She's doing so good at organizing the conference.
Thank you, Quinn, for bringing up and disseminate the conference. This is our inaugural, so we're very excited. We're going to have 12 panels in total, having many different topics, including sepsis, including health equity, mental health, neuroscience, and AI. So we're also going to have one panel looking the perspective of the families and use of AI in healthcare. And the datathon that Quinn just mentioned, we're going to have 2 main topics being developed through with the data that we are being providing through CHOC in sepsis and health equity. And from the datathon, we have a big partnership with AWS, so they are providing to us all the support. So please feel free to if you have any questions, send us an email.
Are you doing a deep racer event, do you know? If that's what they're doing?
Oh,
yeah?
Wait, are we doing a deep racer?
Really?
I'm not exactly sure because we're gonna have a meeting next week with the AWS.
I've done one of
but
those, it's so fun.
We are gonna discuss some details about the datathon. Yeah.
Because that'd be cool. I know they brought it up when we were talking. That'd be fun. Deep racer's fun. If anybody hasn't done it before, you should try.
What's the cost for non-students?
Alina, do you know?
Well, let me just take a look right now. So just give me 1 second.
Or does Chapman want to talk
Deep racer, they give you a digital vehicle that you have to train in a simulation.
Oh, who you was talking about?
And then on the day of, they actually load these like actual race cars with your software and see how you perform on the track.
I think, Alina, you won, right? The deep racer?
I did.
Yeah, her car was lit.
Yeah.
Because I have one of the 2 models. The ones who was on the virtual race, my car did so bad. But in the real race, which was the cars I would say like a Hot Wheels.
Yeah.
They really worked. It's like, I was impressed actually. So.
Yeah.
Oh, cool. Well, while Alina's getting that info up, come if you can. It's going to be super cool. You can hang out with the CHOC people. We love it. And thank you for letting me talk for so long. Right? That's Choco.
They have the name?
Yeah, we're very creative, CHOC, and we're like, it's Choco.
That's how kid naming goes.